ahead and get started on video 222. That is our second video for our second standard from Unit 2. We are still working on writing and interpreting linear and piecewise models, and this time we're going to be focusing on the writing of equations of lines. So there's going to be a couple different approaches, and since we know that there are different ways to write the equation of a line, I'm going to work you through all of those. So the first one, and each of these is going to depend on the information that we're given. If we're given the slope and the y-intercept, so let's just start with that much information. I'm given the slope of a line to equal 2/3, let's say, and I'm also told that the y-intercept is the ordered pair 0, -5. Okay, so if this is my given information, then I want to see how I can write it. Now, the first way I could write it was probably going to be to write this in, let's go with point slope first. Okay. So this is point slope form. Since I have a point and I have a slope, now you're like, well, I don't have a point, I have a y-intercept. Yes, but my y-intercept is a point. Okay, so I'm going to write this as y plus 5 equals my slope times x minus 0. Right? So this actually qualifies as the equation of this line. But what if we wanted to write it in slope-intercept form? Which is probably your go-to form for this. Remember, that's what the students like to call y equals mx plus b, but we're going to try to work in the correct language, and that is that this is the slope-intercept form. And it's very natural to write it like this because I have the information to just go ahead and write it in this form. Okay, so I'm hoping you can see the connection of how we would get from one to the other. And then the last one is, what if I needed this to be in standard form? So how do we take it from this to get it in standard form? Well, if you can recall, standard form was the ax plus by equals c, where we want the a, b, and c to be integers. So I'm going to have to get the x and y on the same side of the equation first of all. So that would be -2/3 x plus y equals a -5. My next step would be to eliminate the rational numbers, the fractions from this, by going ahead and clearing the fractions in order to create all integer coefficients, coefficients being the number in front of the x's and the y's. So to do that, I'm actually going to multiply this one times a -3. And I'm choosing to multiply it by -3 so that I can eliminate this negative as my lead coefficient. So times -3. And that leaves me with a -3 times -2/3 to just be 2x. Don't forget to distribute this to everything within the parentheses here because I'm trying to clear the fraction, leaving me now with a -3y, and a -3 times a -5 equals 15. So this is my standard form of the equation. Alright, let's try another example. This time I'm going to give you the slope and a point, very similar to how we just worked the last one with the slope and the y-intercept. So this time my slope is going to be, let's go with +4, and my point doesn't have to be a y-intercept. In fact, this time I will make it something other than a y-intercept, -2, 6. So we're going to start again using point slope, and you're going to see this transformation make a lot more sense to you. This is point slope, so I'm going to start by doing y minus 6 equals y negative, I don't know, what 4, just 4 times x plus 2. So this is point slope form. It's a completely acceptable form of the equation. Now I'm going to transform it into slope intercept. And to do that, I'm just going to distribute the 4 onto the set of parentheses and move the -6 to the other side. So I'm going to rewrite it so you can see how that works. That means y minus 6 equals now 4x plus 8. Be sure you distribute correctly. And the last step would be to add 6 to the other side. Y equals 4x plus 14. And this is my slope-intercept form. You may be familiar with using it and doing 6 equals, and then you'd have your 4 times -2 plus b, and then solving for b. This will effectively get you to the same place, but if you've already written it in point slope, then this nice transition, just using distribution and moving that other value to combine like terms, will result in the same thing. So the last one would be, how do I turn this into standard form? And standard form for this particular problem, because I don't have any fractions, should be a very natural transition, and it's just moving the x's to the other side. Plus y equals 14. For those of you that it bothers to have that negative out front, you're welcome to go ahead and multiply the whole thing by a -1. And that would leave you with 4x minus y equals a -14, and those are both acceptable answers for standard form. All right, let's go ahead and practice with two points. So this time I'm going to give you 2 ordered pairs. So how about 6, 5 and -7, why not? This could get ugly. -7 times, or comma 5. All right. So let's take a look here, and if I were to write this in our point slope form, the first thing I need to find is my slope. I obviously have points. I got 2 of them, but in order to find point slope form, I need to find the slope. So let's go ahead and calculate. That's the difference in the y's over the difference in the x's. And this leaves me with 0 over -13. So in this case, my slope is 0. So let's go ahead and write it in point slope form. I would have y minus 5 equals 0 times x minus 6. Well, this simplifies to, and this would not be the simplest form of this line, this would simplify to y minus 5 equals 0. Now, it didn't matter which point I chose. In fact, you might even want to simplify this over to y equals 5. So this would be my, well, there really is no point slope form for this one. There's really just a simplified form. In fact, what about slope intercept? Sloped intercept would be y equals 0x plus 5, because that's my slope, and my intercept, I would have to, well, transition this. So this actually turns out to be my intercept. And in this case, I would simplify it down to y equals 5. Standard form in this case is actually all the same. I end up with y equals 5. So let me give you another example where we don't have this unique situation of a 0 slope. And I'm not going to give you an undefined slope. We're going to work with one that is a rational number other than 0. So how about 3, 1 and 2, -4. So let's use these 2 points, and we still need to calculate our slope in order to write it in point slope form. So to calculate the slope, again, we'll do the change in the y's over the change in the x's. That gives me -5 over -1, or +5. So I know I'm working with a slope of +5. And I can choose either one of those ordered pairs. I could have y minus 1 equals 5 times x minus 3, or I could write y plus 4 equals 5 times x minus 2. Both of these are perfectly acceptable or point slope form, because I use the slope and I use one of the points that I know is on the line. Now, to write this in slope intercept form, there's only one answer, because there is only one slope, 5, and there is only one y-intercept. So these both have to turn out to be the same thing. So let's go ahead and verify that they really will do that. Remember, the point is that we want to distribute that 5 and then move the other value over so that we can get this to be in our slope-intercept form. So I have y minus 1 equals 5x minus 15, and I'll add 1 to the other side, leaving me with y equals 5x minus 14. Over here we would do the same thing, y plus 4 equals 5x minus 10, and I would subtract 4 and get y equals 5x minus 14. So you can see that either form of point slope will lead us to the same slope-intercept form. Now lastly, let's go ahead and bring this over to standard form. And you should be pleased that this will be very simple, and we will just subtract the 5 to the other side. Negative 5x plus y equals negative 14. Once again, if that bothers you, you may switch all of the signs by basically multiplying the entire thing by a negative 1, and that will get you to this form. But these are the standard form. Alright, the last thing we're going to look at is what if I gave you a direction and a point? So what if you were told that we have a horizontal line that goes through, and I gave you the ordered pair negative 5, 10. Okay, so horizontal line through this ordered pair. Well, consider if you were to graph this ordered pair that we would have negative 5 and a positive 10. So this would be the ordered pair, and it would have to be a horizontal line. So this is going to be of the form y equals because it is crossing the y-axis. In fact, all of the x values are going to change while none of the y values are going to change. So this would be y equals, well, what does it happen to pass through? It passes through 10. So y equals 10 is the equation of this line. It does have a 0 slope, so that may help you out, but it's just y equals 10. If I have a vertical line, and I were to tell you that this vertical line went through the ordered pair negative 3, negative 4, again, we can consider this by graphing it. And there's the ordered pair. It's a vertical line that has to go through that ordered pair. It crosses the x-axis, which should tell you that it is going to be an x equals line. It is not a function. It is a vertical line with the equation of whatever x happens to be, which is negative 3. There's not a lot of work shown. The graph is a great justification to help you think through it, but it isn't really a necessary step in writing the equation of horizontal or vertical lines. All right, make sure that you address any concerns here, and we will be talking soon.